Okay. Hello, everyone. Thanks for joining us for the Programmers Week. For those who may not know me, I'm Franco Pirovano, and I'm a .NET developer at Cognizant Softvision, where I implement new features and give support to .NET applications. So I've been in Cognizant Softvision for almost 1 year, and I'm really excited to talk about this topic, being security measures when allowing users to upload files on our application. I also encourage you, everyone, to share your questions in the chat module so I can answer them accordingly at the end of the presentation. So without further anticipation, let's get started. So I have divided the presentation into two parts. The theoretical, which I'll be explaining what we are going to be using and giving some fundamentals. All this part is included in this PowerPoint presentation. And then we have the practical, in which I'll be showing some code and how it all wraps up and works. I also want to mention that the scope of this presentation is only focused on validating the files that we receive on the backend using an API with .NET. What this means is that I will not be showing any front-end validation or any save validation post, such as name collision or blob storage on a database. So starting with the theoretical part, we have different types of measures that we can use. In this presentation, I'm gonna be focusing on 4 of them, which are file size check, file extension check, file signature check, and an antivirus check. So before getting into those 4 checks, I want to mention 2 principles. The first being the least privilege principle that basically says that every module, in this case could be the user, must be able to access only the resources that are necessary for its purpose. This meaning that if our business logic only stores or process, for example, an Excel file, it should only allow Excel files in that part of the system. And secondly, we have the zero trust principle, which states that basically never trust anything or anyone. In this case, could be that a file was provided by a user and to not trust that user, even if it's authenticated, that we know who the user is, or authorized, even if the user has the permissions. So one last thing, before getting into the measures itself, I want to mention that the business logic is really important, as it will determine what is the purpose of these checks, of what this check will be doing. And it will give us the correct parameters that we should be using in each case. For example, as I mentioned, if we need to process an Excel file, only allow Excel files. If we know that the file shouldn't be have a size of, I don't know, 1 gigabyte, the checks shouldn't allow it. So it's really important to know the context on which we are using these checks. So the first check is really simple. It's a size file check. So this is a really simple check. We just need to be sure that the size matches our minimum and the maximum parameters. Again, this is important to know the context of the business logic on which we check on where this check will run. Maybe you have a program that accepts large chunks of data, and the maximum value should be really high. But if we know that the user should be uploading a small file, we have to restrict the file size to be as low as we need. Other consideration is that if we know, for example, that the user is uploading a photo, let's say a JPG file, its size shouldn't be, for example, 2 KB, because there's no picture with that size. That's why we also check for minimum size. So then we have the file extension check. This is also a basic check that we should be doing. So as you may know, all files got extensions. These extensions are an identifier of the file type and appear after the last dot. In this example, we have an Excel file with Excel SX. Then we have an executable with .x. Then a Word document that has docx, and notice that in this example there's another dot with a lol, but it's totally ignored because it's not the final dot. And another Excel file, this one has some capitalization, which doesn't affect the extension because it's not case sensitive. Again, I want to mention the principle of least privilege, which in this case, we should only process or store files with the extension that are necessary for the purpose of the business logic. For example, if we know that what we need is to process a spreadsheet data, we should only allow Excel extensions or open document. So in this piece of code, I made the validation file extension method. This method accepts the file name with the file extension that we want to allow. And then it will check if the extension is effectively in the list of allowed extensions. If it's not, it will throw an error. And notice that I'm also converting the extension to uppercase. That's because the extension can be uppercase or lowercase mixed because it's not case sensitive. So here is where I mentioned the principle of zero trust. Even though the user may be authenticated and authorized, even if we have other security layers before this check that only allows the most privileged users to upload a file, they may try doing something like this. Maybe it was on purpose, maybe it was an accident. We don't really care. This is why we have the principle of zero trust. We will always validate and revalidate everything. So what we have here is a user renaming the extension. So if we only have the last piece of code I showed, the check will pass because it's going to see and it's going to say, oh yeah, it's an Excel file. So that's why we have the next scenario, which is file signature check. So a file signature is an unique sequence of bytes written in the header of the file. This means that when we open a file and check its bytes, the first few bytes will determine what extension is actually the file from. Every file extension has its own file signature, and there are some cases that multiple file signatures can be valid for the same extension. we usually read these bytes as hexadecimal. If we see here, we can see that there's 2 file signatures for XLSX. There's plenty sources when we can get these file signatures. I use that one that I'm showing on screen, that it's called filesignatures.net. So when I search this XLSX, it gives me 2 results. One that starts with 54B03C04, and the other one that starts the same, but it has 5 bytes more. Sorry, 4, which will give me more specific data. It's telling me that it's a 2007 document if it has that exactly, but it's still an Excel. So also, if you see the image in the right, we have an Excel file with an XLSX extension open with Visual Studio's byte reader. You can read the bytes on Visual Studio. I have marked the first 4 bytes of the file, and this corresponds to the XLSX signature. So moving on, in this piece of code, I am validating the file signature. We first get the corresponding file signature of the extension that we are targeting, and then we will loop through that list and check if it matches the file signature of the file that the user provided us. If it's not matched, it will throw an error. So here I'm showing 2 images. The first one is a function, which is a byte to hexadecimal converter. So when we are comparing the file signature and the when we are comparing the file signature, we usually do it in hexadecimal. That's why I did that function. And the second one is just the dictionary constant with the file extensions as the key, and a list of lists as the possible byte signatures that we can have for that specific extension. You can store this information in many ways, being SQL database, JSON, or constant like I did here. I chose this one so we can see it more clearly. Now again, we have to mention the zero trust principle, as we may encounter a user that changes the header to match the header that we allow. For this case, we have the antivirus check. This is the final check that I'm showing in this presentation. So before going to this part, I want to remember that if you have any questions at this point, you can make them on the chat, and I'll be answering them in the end of the presentation. So going back, the last step is the antivirus check. This check will allow us to scan a file with an antivirus program. In this case, we are using ClamAB. Now, ClamAB is an antivirus engine, really easy to use, that allows us to detect many types of malicious software like Trojans, malware, basically virus in general. It's open source and you can use it pretty much anywhere as it's multi-platform. Now, note that ClamAB has to be running on a container or a virtual machine in order to use it, as it's not an extension or package you can use it that you can use in your code. It's a software on its own. And for that, we have Docker. Now, Docker allows us to run applications on an isolated environment that we call containers. You can think of a container as a standalone executable package of software that includes everything needed to run a specific application. In this case, we will run a Clam AB. We use something that it's called images that contains the application with its configuration, and that image is what then we run on Docker. The image that we will be using on this presentation is the official one from Clam AB, and I'm pulling it from the Docker Hub. I wanna say a huge note here on how to update this antivirus. This is really important. The image that we download should be at least checked once per week if there's any updates on the image. But the database that ClamAB uses to check virus should be updated at least once per day. You can update its database using a command that is called freshclam. It is recommended that we do this well, once per day, as the virus signature database gets updated really frequently. And this will ensure that the ClamAB client is up to date. So to run the ClamAB image on a Docker container, we have to run some commands on the command prompt. I'm using Windows. The first one being the pull, that it will download the latest ClamAB image. Then we have the run command that it will instantiate the image on a new Docker container. And then, in that command, we have two optional parameters. The first is the D parameter, which is like the attach. So when I'm running that command, it will let me run other commands, because if not, the command will attach to the Docker process and won't let me continue writing other commands. And the second command is the P followed by the port numbers. This will create a connection between our local host with the port given and the port that the image will use. So that's how we connect to the Docker container. Then we have three more Docker commands. We have Docker PS with an L as parameter. This will list all containers on Docker. Then we have the start and the stop with the container ID. These are simple commands. And for the last part of this explanation, we have how to connect the .NET code with the ClamAB instance. First, we need to install nclam package to our project using Nugget Package Manager. We will have to set the ClamAB server URL and port number. I use the configuration file from the project. Then we will send the file content to ClamAB, and will it return the scan result. This result can be a clean result if it didn't detect anything weird. Then it has the virus detected if it detected that the file has a known virus. An error if the file couldn't be read properly or something happened to the file in the middle of the reading of that file. Or unknown if something it's something that didn't match any ClamAB criteria. It would just throw an unknown. And finally, we have an exception that for most cases we will get there if there was an error connecting with the ClamAB instance. So that's it for the theoretical part. I'll be moving to the practical. I'll be showing a little bit of code. So first, I'm gonna run the. I'm not gonna run the Docker pull because I already have the image. So I'm just gonna do the Docker run. Great. If we go to the Docker, if we go to the Docker application, we can see that it created a container with that image. Now, I'm going to show the files that I'll be using. We have the correct file, a file that has a run size, this one has a run extension. And this one, I'll be changing PDF to XLSX, and it should not match the signature. So I have the code here, it's running. I have Postman, and I'll be using it to connect to the API. So I'm not using any headers. I just have a body here. I have the keynotes file that matches this one here. And I'll be throwing a file here in the value. If I hit send, it will stop here. If first I check that there's a file, I then check which extensions I'll be using. Here I read the file, and here I have all the bytes. Well, the first one is the size validation. Then we have the extension validation, and then we have the signature validation. So, lastly, we have the antivirus scan. And we have it clean. So everything is okay with that file. And it returns out 2000 okay. So now I'm going to choose, for example, the run size file. As business logic, I only allow files that are more than 15 kilobytes of size. This file has 7 only, so I send it, and it should throw me an error here. It says the file is too small, and it returns that text here. Then I tried with the run extension file. I send it, and if I get into the file extension, it will throw me an error that the extension is not match the list that we provided. And the last one is the wrong signature file, which was a PDF, but we renamed the extension to XLSX. So it goes through those validations, and when it gets to the signature, here I have the signature dictionary that has multiple signatures. Then it loops through the possible signature that are these two. And then it will check if the hexadecimal code of the file that we are using matches the file signature of what we have in our system as the correct one. As it didn't match anything, it will throw an error. So basically, that's it for the presentation. Thanks all for listening.